Hey guys, so this video is going to go over a couple of the story problems that we've been doing this week. It's all the trig stuff we've done, where you're drawing pictures, creating triangles, figuring out what you're solving for. We did these 4 in class. I wanted to make a video for you just in case you missed, or if you wanted to hear them again. The remaining 8 problems, because there's 12 total. The 8 that I don't go over are your assignment. So make sure you're working on that. We're going to be checking those on Monday. So please make sure you're getting caught up on that. If you have no idea how to do this because you haven't done the other videos, go back and do those first. Okay, you can't do the story problems based on trig if you don't know how to do just basic trig. Okay, so just something to note with that. First one we're going to tackle already has the picture drawn out for us, which is great. It's always nice when they have that. But you still need to go through, read it, and underline your key features. So we're leaning a 20-foot ladder against a wall of your house. The base, or the bottom of the ladder, is 4 feet away from the wall. And you're looking for the angle that the ladder makes with the ground. So those are all really important things we kind of need to know. The 20-foot and the 4-foot are going to go in the problem. The angle is what we are looking for, so that's kind of good to know. I'm going to put an X by that. So in the picture, they've already got that laid out for us. Here's the wall of our house. Hits the ground at a 90-degree angle, or we are assuming so because houses usually do. And then here's our ladder, so there's our triangle. This little symbol right here is called theta, and it's spelled like that, theta. T-H-E-T-A. It's the symbol just that we use, especially in upper level math, for when we don't know an angle. It's just what you put there, kind of like X, just a variable. I'm going to redraw the triangle over here because I don't like having a bunch of extra stuff there. I kind of like to just sketch my own real quick. It's 4 feet away from the base of from the wall. And then here's our ladder. All right, cool. Let's start with our labeling then. We've got our triangle all worked out. We're looking for this guy. So this is opposite, this is adjacent, and this is hypotenuse, which means hypotenuse and adjacent are our sides that we are going to use. All right, well, remember your SOHCAHTOA. And some of you are having trouble with those letters. Think about the phrase, some old horse caught a horse taking oats away, if you're having trouble remembering which letters go where by just saying SOHCAHTOA. Adjacent hypotenuse means we're going to use cosine. So cosine of x, follow this. Adjacent over hypotenuse means you have to put 4 over 20. Now, because we're looking for an angle, hopefully that kind of sent a little signal to your brain saying we need to do inverse trig. That's where you do the second or you hit shift on your calculator. The reason we do that is because we're trying to get rid of this guy. We're trying to get x by itself, remember? I can't get rid of cosine unless I do inverse cosine. Kind of like how square roots undo squaring, addition undoes subtraction, that kind of thing. And if you've watched the other videos, that's kind of old news. We've talked about that a couple times. But x is going to be equal to the inverse cosine of 4 divided by 20. And if you plug that in correctly, you should get 78.46 degrees, I believe. That's what I got, so I'm hoping that I did that correctly. I'll do a quick check just to make sure that my key is correct. Sometimes it's not. Looks like I'm good. All right. And since it's an angle, make sure you put degrees on that. Again, this one's pretty basic because they already had it drawn out for us, so I'm not taking too long on that. The next one we've got is this guy. So now we're going to start actually drawing the pictures ourselves. And a lot of you guys just are drawing triangles, and we really don't want you to just draw a triangle. Okay, if I'm talking about me standing 350 feet away from a skyscraper, I want to see a skyscraper. Okay, now if you get the right answer, that's great if you can do it without this, but a lot of you are missing easy stuff because you're not drawing in the picture. Put a dang skyscraper in the picture, people. It's not that hard. It doesn't need to be a beautiful work of art. See, that took me all of like 10 seconds to do, maybe 15 seconds, and we're done. Okay, then you can start sketching your triangle into the picture. Okay, my angle of elevation is what I'm looking for. So basically from the ground to the top of the building, or from me to the top of the building, how many degrees is that? That's what I want to know. I'm standing 350 away from the skyscraper. The skyscraper is 750 feet tall. We're looking from that. Okay. The skyscraper itself is 750. Now, a lot of people got confused with this 350. Now, remember, if you tell somebody you're 350 feet away from something, are you telling them you're 350 feet away from the top of that object or from the bottom? Generally, we refer to the bottom. Okay, that's just kind of general consensus that if you're standing 350 feet away from something, you're assuming that it's from the base of the object, not the top. Okay, really, that's the hardest part, is figuring that out. I'm missing one thing in my picture. I'm missing that 90-degree angle, so you really got to make sure you put that in there. It goes right here. And if you need to, here is your triangle. If you really need to sketch that outline just to help yourself find the triangle, that's fine. But you really do need to get all that stuff in first. All right, from here, it's really just what we've been doing. I mean, the hardest part of these problems, honestly, is getting these pictures drawn. That's the toughest part. Here's your hypotenuse. Opposite of x, the angle, is over here, and adjacent's down here. Again, I'm not taking a ton of time to go through these problems once they're drawn out, because this really is the basic trig you've done. If what I'm saying after this point doesn't make sense, you probably need to go back and watch one of the other videos. Just because this is something that's a little bit more old once we've gotten to this point. If I'm using adjacent hypotenuse, you've probably already figured out that it's tangent, which is the TOA abbreviation. So tangent of x, I have to go opposite adjacent, so 750 must go on top, 350 must go on bottom. This is an angle that I'm solving for, which means I must use inverse. That's where you gotta hit the second or shift or whatever your calculator does. Because I'm trying to get rid of this guy. Inverse tangent on both sides. Looking great. And as magically as it happens, those erase each other or cancel out. And we have x is going to be equal to whatever the inverse tangent of 750 over 350 is. Okay, and I already did the math for it. Go ahead and plug it into your calculator. See if you get the same thing I do. You should get 64.98 degrees again, because it's an angle. We need to label it properly. And there you go. That's your answer. Oops. Okay, so your number 3 is right here. If you need to rewind or pause or whatnot, feel free to. But I'm moving on to number 3. Go ahead and read through the problem yourself. And we're going to underline our key features here. There we go. Okay, I'd say those are the big key features. Again, draw your stinking picture. I don't care if it's magical and beautiful and an artistic wonderfulness. Just draw a dang picture. Okay, here's the weather balloon. It's basically a hot air balloon. That's what she's in. She's floating in the sky in a hot air balloon. Okay, and we're going to draw her car down here. See, it's not beautiful. It's just a basic looking picture. There's your car. Okay? Took 15 seconds to do. Draw it on your dang picture. She wants to know the direct distance from her to the car. There we go. Kind of a wonky line. Altitude means height. If you ever go hiking, they usually tell you the altitude of the mountain so that you know how tall the mountain is and how much you have to hike. Planes have it as well. Just means how high up in the air you are. So that one's pretty easy to label. That one's 82 meters. That one doesn't really surprise anybody. This angle of depression is where we usually get kind of messed up, though. Okay? This angle of depression, if you guys think back to what we learned a couple days ago. You had this picture on one of your notebooks and it said you have to have a horizontal line. And if you go up from that horizontal line, that's an angle of elevation. If you go down, it's an angle of depression. Okay? Now, the issue here is if I connect this and make a right triangle, first of all, I told you we have to use a horizontal. That means going left to right, like this guy. The only horizontal line I have is right here. If I go up from this line, that's technically the angle of elevation. I really want the angle of depression. Okay, because of that, your angle of depression isn't actually in this triangle that I drew. It's actually on the outside up here. If I draw a little horizontal line going this way, it's parallel to this guy, so it's okay. Going down, there's my angle of depression. My angle of elevation is right here. Okay, now that kind of frazzles a lot of people because they're like, what do I do with the angle of depression now? Okay, well, there's a couple things you can do. Some of them you might have already been thinking of, which is awesome. If I extend these lines a little bit, what's kind of cool about angle of elevation and angle of depression is that they are congruent to each other. If you look at this angle and this angle, they are actually alternate interior angles. Remember back when we did the transversals? Those are alternate interior angles. That's what these guys are. So angle of depression and angle of elevation are actually always going to be congruent to each other, which means I could just automatically plop a 32 degrees right there and right there. Okay, so that's one option. You could just put 32 there and then use this triangle as usual. Okay, from there you could solve, you're looking for the direct distance like we said, so x would be there, so you can do that. Option number 2 is if you didn't remember that this is equal to this, maybe you realized that you could solve for this angle. Okay, this angle plus this angle have to make a 90-degree corner. Okay, well, if this is 32, then to make 90, this has to be 58 degrees. Okay, so maybe you didn't know this part, but you knew this part, and you could make a triangle that way and use the 58 degrees like that. Third option you could do is you could just make a second triangle. Whoops, that was bad. You could just make an upside down triangle. It's going to work exactly the same way. 82 is still going to be up here because it's still how high up she is. It's just moved over a little bit. X is still here. You're still looking for the direct distance, and you would use 32 here. Okay, so lots of different options you can do. All right, now I'm going to skip over the actual solving for this part because I feel like you guys can do that at this point. If you really need to see the work for it, feel free to check the PDF that's attached to this, but I only have so much time, so I'm going to go to example number 4 real quick and just show you how to set it up. Now, while I'm setting up this picture, and getting everything underlined, I want you guys to realize that this is actually a legitimate problem. I know some of the other ones are kind of weird, like not many people need to know the angle of their ladder necessarily, but what's happening in this problem is actually something they do. Many times we can't measure distances across big bodies of water or big land masses, so they use trigonometry, because I can't exactly run a tape measure across a pond. They use trig to help them determine the approximate distance across for things such as building bridges and maybe figuring out fish population, especially in this area with hunting and things like that. That's pretty big. Okay, so here she is. Here's her tripod. Okay, so the big thing here, here's her tripod. It's looking across the water. There's a little device on the top that tells her this is 18 degrees. She's looking for X. Now the issue here is that the tree is 27 feet tall, but her tripod is 3 feet tall. Well, the problem with that is that her tripod is not looking at this 18 degrees from ground level. It's looking at it 3 feet off the ground, which means in reality this side is no longer 27. You have to take off 3 feet and make it 24. From there it becomes pretty usual It's the same as what you usually do.